Hello everyone, welcome to another video. This time we're checking out another thing about solving, specifically solving versus simplifying. Now lots of people out there might be like, solving and simplifying, aren't those the same thing? And no, they really are not the same thing. We're going to look at how we can tell them apart, how we can tell which one we're doing, and then we're going to wrap this thing up. Now, before anyone feels like frustrated about having maybe mixed up these two words, just want to start by saying it is not your fault. This is a really common thing in high school and even in college mathematics. Lots of people misuse these words. Teachers misuse these words. Students misuse these words. So we're not like trying to be extra. We're just trying to focus on the idea that these things are different. And if we can identify those differences and identify which one we're actually doing, it will help us be more successful in math. That's our goal, to be better at math. And we think this will help. Now that said, let's jump right into a giant block of text. Okay, we're going to send this to you, so don't stress too much about this, right? Let's just go through these 6 different kind of like descriptions of each side and see how these things are different. So for simplifying, the goal is to rewrite or rewriting an expression or equation in its simplest form. So we are writing something that is the same thing, but it is simpler written, right? For solving, the goal is undoing. Oh, that's such a big word for solving, right? Undoing one side of an equation. It's, yeah, like undoing one side of an equation to find the value of a variable. These are very different goals, right? Uh, for simplifying, it says mostly for expressions, but it is possible to simplify either side of an equation. Okay, so simplifying can be done with expressions or equations. Solving must be an equation. If you have an expression, you are not solving. You must have those equal signs to be solving. Simplifying could include variables or not. We did lots of examples with both those things. But solving must have a variable, which makes sense because your goal is finding the value of a variable. And so if you don't have a variable, you can't find its value, right? These next three really, to me, kind of highlight the relationship between simplifying and solving so well. For simplifying, you perform operations normally, meaning if you see addition, you're adding. For solving, you do inverse operations. So we have like normal operations for simplifying and inverse operations for solving. So if you see addition, then you're subtracting. For simplifying, we looked at our steps of operations. You go down the steps of operations, right? We start at those powers and roots, and we work our way down the steps when we're simplifying. But for solving, you go up the steps. It's the opposite direction. We start by undoing addition, and then we undo steps further up. And this last one, right? When we simplify, we start inside of the parentheses. And if we have multiple parentheses, we start all the way on the inside, right? For solving, it is the opposite. For solving, we work from outside the parentheses in. So we start all the way outside the parentheses, right? On the furthest outside spot, and then we work our way in towards the middle. So let's see. So we have like normal versus inverse, we have down versus up, we have inside versus outside. These are all the words of inverses, and that's kind of what simplifying and solving are. They're inverses. That's why it makes sense that we mix them up, because they're related, but they're definitely not the same thing, right? Addition, subtraction, related, not the same thing. Okay? Let's look at some examples where we're going to try to determine if we are simplifying or solving. So here we have 2 examples. We have one on the left, one on the right. Are we going to be simplifying or solving if we're like doing the, the math of the steps here? Let's look at what this person did actually to kind of like do their work. Okay, so here we have, I can see a couple things really quickly, right? So here we have an equal sign. Here we have a variable. And here we have some inverse operations. Those 3 things, specifically the inverse operations, right? That kind of screams out to me, oh, this person is solving, right? And look what they did at the end. They found what x was equal to. So if you describe this work as solving, That would make sense, right? This person's solving. Over here, well, let's see, right? So, okay. Oh, okay. So it starts with, it looks like this person is distributing, and I see a variable right there that I erased. Ha ha ha. I see a variable here, but one thing that is greatly missing, right? There's no equal sign. This is just an expression. So this person is doing these operations, they're distributing multiplication, they are combining like terms. All those things would fall under simplifying. And notice how it ends. It doesn't end with x is equal to or anything like that. It just ends with another expression, which is the same as the original expression. Okay? So we can kind of see what we were talking about in that list here. Is there an equal sign, yes or no? Are we finding the value of a variable? Are we doing inverse or regular operations? Let's look at one more. One more, simplifying or solving. So here we go. Here's this 2 times x minus 3 plus 4 equals 12. Okay, let's see. Let's see what, okay, so it starts with distribution. And then right here, it looks like they're combining like terms. Those things to me seem like simplifying. But then, oh, then we shift into using inverse operations and finding the value of x. So in this case, we would say that this person is doing both. This person starts with simplifying. Like these kind of this first chunk, that's all simplifying, right? Because notice how this 12 over here is just sort of staying the same the whole time. The person's working with a single side of the equation, simplifying it. And then once they get it into its simplified form, right? 2x minus 2 is the simplified form of that top left expression. Then they start solving, okay? So it's not that we can use either word for what this person is doing. It's kind of like there's different parts to this process, simplifying versus solving, okay? Hopefully this difference makes sense, and hopefully you're like, oh yeah, I'm cool with that. And we can all push ourselves to be more consistent about using simplify when we mean simplify, using solve when we mean solve. Take care, everybody.